Hello everybody, welcome back to another NumPy video. The focus of the next couple of videos is going to be on converting from binary to decimal. If this is your very first time ever seeing binary and decimal and the conversions between the two, I highly recommend you check out the short videos I made about the topic. I'll link them in the cards above. Otherwise, the goal for this video is we're going to write a function called toBin, which takes as input an m by n a NumPy array of zeros and ones, and as output returns the corresponding, I'll call it base 10 integers. So let me fix that really quick. And we think of each row of the array as representing the digits of a binary number. So for instance, in this first one here, this is 0 times 2 to the 0, plus 1 times 2 to the 1, plus 0 times 2 squared, plus 1 times 2 cubed. So that means 8 plus 2. That's how we get 10. So let's get started. For our function, I'm going to say def to underscore bin, and I want to return, let's just call it x for now. So what we're going to do is before we actually fill in the details for this function, and what am I missing? I haven't specified an input. Let's say ARR. But as I was saying, before we fill out this function, let's practice a little bit outside of it, see if we can get the basic structure to work, and then once we're confident that we have a method that works, we'll go and write the function. So first off, let's start by creating this type of array. So I'm going to instantiate a new random number generator. I'm going to say RNG equals np.random.default underscore RNG. And I also should have NumPy imported, so let me do that before anything else. Import NumPy as np. Here's our random number generator. Now let's say ARR equals, and let's do RNG.integers. Now remember, we want 0 and 1, so we can say this means go up to 2 but don't include it. And the size doesn't really matter here. Let's say we have a 10 by 4. Oops, and let's see. I spelled integers wrong. Integers. Let's take a look at ARR. So we can see here, this first one is 1100, so this is 2 to the 8 plus, or sorry, not 2 to the 8, 2 cubed, which is 8, plus 2 squared. So this first one should be 12, but we'll double check that when we finish writing our function. So there's ARR. Now, like I said, here we have 2 cubed, 2 squared, 2 to the 1, 2 to the 0, and we want to multiply across by 1. Basically, we want to multiply across like component-wise. So what we should do first is let's get the dimensions of ARR. So I'm going to use something called tuple unpacking, which is where I specify, I know the shape of ARR it's a tuple with length 2. So I'm going to call the first entry M, the second entry N, and I'm going to let this be a shape of ARR. Oops, what did I do wrong here? It should be ARR.shape. Good. Then we can take a look and see, well, what's M? 10. What's N? 4. Now, what we want to do is we want to start at 2 to the n minus 1, because remember, we're starting at 2 cubed. So I'm going to say mp.arange n minus 1. I want to go to 0, so I should end at -1. Remember, this says go up to -1, or really down to -1, but don't include it. Decrease by -1. So this one is telling us where to end. This one is telling us how to increment. And if we take a look at this, we get 3, 2, 1, 0. And these are the powers that I want to take 2 to. So if I do 2, raise it to this np.arange, I can see here I get 8, 4, 2, 1. And now all I want to do is multiply these numbers across every row of the array. So the way we can do that is I can just say ARR times, now I'm going to take this, and again, using our broadcasting rules, this should work just fine. So we can see here we got 8400, 0421, so looking good so far. Now remember, all we need to do now is just sum across the rows like this. So summing in this direction quick sanity check and or quick really quiz question. Which axis is this? Should be axis equals 1. So I'm going to say dot, let me wrap this in one more set of parentheses, dot sum, axis equals 1. And we can see here 12, 7, 2, 0. So everything must have been 0 there. Yep, all zeros. And like we said, the first one is 12. So all right, this is looking really good. Now all there really is to do is move this code into our function. So remember, what was the first thing we did is, or really we could do it all in this line of code. So I'm going to bring this up here. And we really can just say return this guy. But the first thing, I guess one thing I'm missing is the shape. So I'm going to say underscore comma n, because remember, we didn't use the first dimension of ARR, we only used n, so I'm going to use an underscore to highlight that it's not used. And this is ARR.shape. And we can run this, and now let's test it. So I'm going to say to bin ARR. And we can see here we get 12, 7, 2, 0, and so on. So that's looking pretty good. Let's do one example that we can compute pretty fast. So I'm going to say to bin, let's do np.array. And let's say I have 1, 1. So that should be 2 plus 1, that should be 3. And then let's say I have 1, 0, so that should just be 2. So we can see here we get 3, 2. So this is looking pretty good. In the next video, we'll see a different way of making the same function. And in the video after that, we'll talk about how to raise some errors. So how can we check that the inputs are what we expect? Thanks for watching, and I'll see you in the next video.